This is Science Max, experiments at large.
Science Max!
Rube Goldberg machine!
Rube Goldberg machine!
Rube Goldberg machine!
Rube Goldberg machines!
Rube Goldberg. You heard me say Rube Goldberg machine. Okay, we got that part? Okay, good. Rube Goldberg was a cartoonist who came up with the idea of having a simple task done by a machine that was extremely complicated. There are Rube Goldberg competitions all over the world, and there's only a few rules. First, a human can only touch it once by starting the whole thing off, and then the machine has to work all on its own. I know what you're thinking. You're thinking, Phil, what's the science behind a Rube Goldberg machine? Well, it's all about changing energy. Remember, you start the whole thing off with just a little push. But if you want the machine to keep going and going and going, you have to come up with clever ways to add more energy to the system so you've got more energy to keep the machine going. So check this out. A bunch of stacked dominoes, which will start a chain reaction that leads to this mousetrap, which has all of its energy stored in the spring tension, which will release the ball. Boing! Check this one out. It's a bunch of pulleys, and there's a rope that goes up and down and up, attached to this lever where there's a ball, and there's a big heavy weight here. And when the weight gets knocked off the table, the ball falls into the hole and then goes down the tube, and so on. Check this one out. Here's a great way to change the direction of something. Say the ball falls on this lever. Well, it's weighted on this end, but then the weight falls off, and the ball goes this way. And today is all about mechanical advantage, like this fulcrum and this lever, transferring a lot of force over a short distance or a little bit of force over a long distance, and vice versa. We are going to be building a trebuchet. A trebuchet. So a trebuchet looks a lot like a catapult, but a catapult uses elastic force to throw something, and a trebuchet uses the good old lever. There's a lot of weight on the short end of the lever, and on the other side of the pivot is the long end, and we've got a sling here with a marble in it, and we put that down here on the ground, and then we let it go, and whoosh, whoosh, it throws the marble. To build your trebuchet, here's what you need. Something to be your lever, like a pencil. Something to be your weight. I used batteries. You'll need to make a frame, and I use craft sticks and cardboard for that. A way for it to pivot, like a straw and a shish kebab skewer. Then you'll want a sling, which is a rope, and something to hold your projectile, like plastic netting. Finally, something to hold it all together, like glue. Get your craft sticks, make some triangles with one craft stick sticking up. Then get your craft sticks and make a base which you will put on with your cardboard like that. Now you'll also probably want to make some extra supports that go off the bottom there like that. Then get your pencil and cut a piece of straw so that you can see right through it, and you can get a shish kebab skewer and you stick it through the straw like that, and that's your pivot point, your fulcrum for your lever. What you want to do is put your weights, I've used some batteries, you can use anything that's heavy, on the short end of the lever. That's important because a lot of weight here translates to a little bit of weight going a lot faster on the other end. So, a lot of weight on the short end, and then on the long end of the pencil where the eraser is, you want to take a toothpick and stick it into the top of the eraser and then cut it off so it's just like that. That creates a little hook that you put the loop of your string net on so that when it gets flipped around, the loop comes off and then throws your projectile that way. And then, of course, you need something that you want to fire. I like to use marbles, but gumdrops work pretty well because they're nice and soft. And you put it in and you pull it all the way down, all the way so it's actually resting on the cardboard like this, and then you let it go. And it fires. And there you go, a trebuchet. Now, if you want to research how to build one of these yourself, it is called a trebuchet. Haha, trebuchet. Wait, I can make it come up, but I can't make it go away. I don't know why that works like that. Huh? Check it out. So, if you take two syringes and you take a hose and you attach them to something you want to remote control, voila, you can build something like this. We have made our very own robotic arm that you can power remotely with hydraulics. Pretty cool, right? If you want to build one of these yourself, here are the materials you need. First, you need two supports and the arm. I used pieces of wood, but you can use wooden spoons, rulers, or pencils. You'll need some craft sticks, elastics, and a paper plate.
And of course, 2 syringes and a hose, which you can get in an art supply store or a hardware store.
Here's how you build your own hydraulically powered arm.
First, make the base by tracing holes for your supports the width of a craft stick apart. Cut out the holes and use a craft stick and elastic to secure the supports underneath the plate and on top. Then add some elastics and a piece of craft stick in the middle so the supports won't scrunch together.
Because we are holding this whole thing together with elastics.
Then get your syringe in there and keep it propped up with more elastics. Then get your arm and slot it in between the supports. The arm should be horizontal when the syringe is half full. Elastics to attach the arm and the syringe.
Then push down on this end of the plunger and, ha-ha, you have a remote-controlled robotic arm. You can also max it out even more by adding more degrees of movement. You can make the arm rotate side to side. You can even add a little claw attachment at the end and power it all using syringes. Haha, science and hydraulics. We are going to make a gyroscopic whirligig, and it spins, and I don't, which is a good thing. Watch this. You pull the string and, it spins and it stands on its end.
Why does it stand on its end when it spins? Because of angular momentum, which we'll get to later.
And here's how you can make one of your own.
You will need some craft sticks, string, a small zip tie, a shish kebab skewer, spacers like these wood blocks, and finally some round discs, which you can cut out of plastic or find from parts of broken toys. Now, if you want to research this yourself, look up Gyroscopic Whirlygig.
Get 2 craft sticks and glue them to your wooden blocks just like this, and then do it again.
Space them apart and glue them to crosswise craft sticks, and this will be your launcher.
You put your hand in the small end, and the longer end here is where you put your gyroscopic whirligig. Now let's make that. What you want to do is you want to take a shish kebab skewer or whatever fits the diameter hole of the round things that you're using. I like to use little plastic discs from, these are from remote control mechanisms, but you can use anything you want.
I found that this launcher works best with 4 discs of the same size.
Just like that.
Space them out evenly, glue them down, and cut the skewer even on both sides. Then add your zip tie. Put it right in the middle, tighten it up, and cut off the dangling end. This zip tie just gives you somewhere for the string to hold on when you wind it up. Now for your pull handle. Glue 2 craft sticks and 2 wooden blocks, then 2 more craft sticks on the sides. Then tie a string to the middle, wrap that string around the middle of the whirligig, and
ha! You have a gyroscopic whirligig, a pull handle, a rope, and your launcher. Now remember, you put your hand in like this, and you fit your gyroscopic whirligig in just like that, and you pull towards you, and it spins. Oh, and that's what we're gonna be doing today, Science Maximites. We're gonna max out a spinning rig, something like this. It's gonna spin bigger, faster, more weight. It's gonna be totally maxed out. Today, we are going to be building a Gumdrop Dome. And gumdrops are already kind of dome-shaped, but they don't hold a lot of weight. Yeah, can't hold much weight. But you can make it hold a lot of weight if you build a geodesic dome. A geodesic dome means a round shape made out of straight lines, and that's what I've made here. All I used is gumdrops and toothpicks. It's very easy to make, and I'll show you how to do it. First, you need to start with a pentagon, a 5-sided figure. 1, 2, 3, 4, 5. And then stick them all together, obviously, with toothpicks. Then what you want to do is you want to start making triangles. So you stick a toothpick in here and a toothpick in here, and then you put a gumdrop at the top of this triangle, just like this. And then you make another triangle here, and here, and here, and it becomes a whole bunch of triangles, you see? Easy to make as long as you start with a pentagon on the bottom. Now, once you've built one, I suggest you build 2 more, because then you will have a stable base and you can see just how much weight these hold. Yeah. You wanna max it out? Oh, okay. Let's max it out. Oh, a little collapsing, but still not bad for gumdrops, right? So there you go, the geodesic dome. That's what you research if you want to learn how to build one of these for yourself. But now, let's max this out even more. So, let's dive into the world of polymers and make some slime! Yeah, too mad, not enough scientist. I'll keep working on it. Anyway, to make slime, take your white glue and pour in an amount. It really kind of depends on how much slime you want to make. Now, you want to add about twice as much water as that. Yeah, somewhere around there. Great. Now we want to put in just a little bit of soap. Maybe there, that's good. And you want to put in your food coloring. I like green. Green seems like the right slime color to me. It's the right appropriate mad scientist kind of slime. And then you want to start mixing that up till you get the right kind of consistency. That means make sure the glue and the water are equally mixed up. Good. And now we're ready to make it an actual slime by bonding the polymers together by adding liquid starch. Very good. And you want to mix it up.
When you add the liquid starch, it starts to bond the chains of molecules together, changing it from a liquid to a slime.
It's coming along. And there you go, slime. Now, if you want clear slime and not opaque slime, you want to use clear glue and not white glue. But that's basically the recipe. So there you go, slime. Too supervillain? Yeah. Today, Science Maximites, we are going to be looking at chemistry. Chemistry is when two molecules combine to make another molecule. Like magic, ooh. So let's take a look at what will be powering our chemical rocket. It's an antacid tablet.
When you put an antacid tablet in water, it makes little bubbles of carbon dioxide gas. This happens because of a reaction between two kinds of molecules called acids and bases. Like vinegar and baking soda, but all contained in a small package that won't start working until you put it in water. If we contain the reaction, the carbon dioxide gas builds up and creates pressure.
High five for science. All right, so let's look at our chemical-powered rocket. What you need is one of these. This is a film canister. And ask your parents what that actually means because they're not used for holding film anymore. You can get these at craft stores, though, to hold paint or little things. But really, all you need is a plastic container with a good lid that snaps on nice and tight and keeps the air in. And then, of course, what you need are your antacid tablets and a little bit of water. So pour in some water and then put in your antacid tablet and snap the lid on. Flip it over and wait for the carbon dioxide gas to build up, which will build up pressure, which will launch your rocket. Ha-ha! So there you go, a chemical-powered rocket. Come on, let's max it out. So let's get designing our egg drop experiment. First, you're gonna need an egg. No! Why? Everything's fine. 1, 2. Right, so where were we? Yes, you need an egg. And you need an adult's permission just in case you make a mess. Now, there are 2 ways to approach the egg drop strategy. You can cushion the blow, or you can slow the descent. And there's tons of ways to do either of those things. Cushioning the blow, pretty easy. You get a whole bunch of soft stuff that the egg can fall into so it doesn't break when it hits the ground. Or slowing the descent, you do something like this parachute idea, and it slows the egg as it falls so it doesn't hit the ground with as much force. And you see, the egg is totally fine because it went slowly to the ground. Now, this episode isn't just about dropping eggs. It is about material science. The kind of materials that you use make a big difference. Styrofoam, tissue paper, very light plastic, very light string. If we were to say use different materials for our parachute version, say wood instead of styrofoam and heavy string and very heavy fabric, I wonder if this would work as well. No, it doesn't. So there you go, Science Maximites. Materials make a difference. And that's what this episode is all about. Material science. cutting edge materials, new materials, and dropping a whole lot of things to see if they break. Today we're going to be making a gravity-powered boat. Ta-da! It's pretty easy to make. You just put water in the top here. Gravity of the water pushes it out the straw, and the boat goes forward. And it's super easy to make. You only need 4 things.
A piece of styrofoam, a plastic cup, craft stick, and a straw. And the tools you'll need: a pen, a craft knife, and the help of an adult, and science glue.
Which is the same as regular glue, except I only use this glue for science. You take your styrofoam and you cut it into a boat shape. That requires the knife and the help of the adult. Then take your cup and draw the circle that your cup will sit in. And then you want to put 2 slashes with your craft knife in there. Again, get the help of an adult if you need it. And then start carving out the styrofoam with your finger and make a nice little indent just like this for your cup to fit in. See? And then it fits in nice and snug. So then what you want to do is you want to make a hole in the cup. You can use a pencil. The hole has to be just big enough for the straw to fit in. First, you want to take the straw and dig up in this direction so that it will be a nice angle for the water to come out, and then you want to get the straw back up into the cup like that, and then glue it so that it is not going to leak any water. And then in the final step, and this is your choice, you don't have to do this, but you can use your craft stick and you can make a rudder, or if you want, you can make a whole keel, which goes just like that, and it is right in the middle of the boat, and this helps the boat go straight, because sometimes the straw goes off to the side one way or the other. Okay, water-powered boat. Actually, it's a water and gravity-powered boat. You see, what you do is you fill up the cup with water, and the gravity of the water in the cup pushes it out the straw, and the boat goes forward. And this is what it looks like in the water. You fill up the cup, and the gravity pushes the water out that way. The buoyancy of the boat keeps it afloat, and good old Newton's third law, for every action there's an equal and opposite reaction. The water going out the straw this way pushes the boat that way, and it works pretty well. Whoa, if it's going straight. That's why we have the keel. Okay, so gravity-powered boat. Time to max it out. As you may have already guessed, today is about friction, and here's a really easy friction experiment you can do at home. All you need is a piece of wood. You don't need the frame, and you don't have to do anything fancy to it. Just put one end up on a couch or a coffee table and make a nice ramp. Then you want something to slide down that ramp, and I like to use a piece of wood. Now check it out. Wood ramp, wood block. The friction is so much that the wood slides to there. Now what I like to do is take a little flag and mark the results. Recording the results is good science. Now here's where it gets fun. Get another surface and attach it to the wood, like carpet and wood. Let's see how far this goes. Not as good. All right, record the results. Cardboard. Ooh, nicely done, cardboard. Foam. And this wood has been waxed, like on a floor wax, which makes it nice and slippery. Let's see how that does. Ooh. And now the ultimate ice attached to wood. This is actually harder to do than I thought. All right, let's try it out. Ice! The clear winner. Not a big surprise right there. And get this, once you've done all of that, you can change the surface of the ramp. You can go to waxed wood, carpet, foam, cardboard. Well, well, yeah, you get the idea. Record all the results, compare them, and there you go. Friction ramp experiment. And that's what we're gonna be maxing out today. So come on, let's go. What we're gonna do is build this. This is the Mousetrap Boat, and it works like this. I've got the mousetrap, and it's attached to a long arm. That arm has a string on it, and it goes around the paddle wheel. And as the mousetrap unwinds, the paddle wheel spins like that, which pushes the boat forward. Now, it looks kind of complicated, but it's actually quite simple to make, and here's what you need.
My Mousetrap Boat is made with styrofoam, craft sticks, and elastics. You'll also want a pencil, plastic drink caps, a shish kebab skewer, small zip ties, string, and of course your mousetrap. Now, mousetraps can hurt your fingers, so get an adult to help you when you use them. Start with 2 pieces of styrofoam. I like to cut mine into this shape, but the only really important thing is that they're the same size. Your paddle wheel is made from a circle of styrofoam with it penciled through the middle, and it will go across like this. To make the paddle wheel, I use cut pieces of craft stick.
Or they can be plastic, and make some cuts and then put them in like this, and that is what will make your paddles on the paddle wheel, because that's the wheel and that's the paddle wheel. That's why they call it that.
Stick drink caps to the ends of the pencil after sticking it through the styrofoam. I like to use a few craft sticks and elastics to help give the styrofoam strength. Next is the mousetrap, which you want to glue down to a frame of 4 craft sticks. Attach the frame to the boat with elastics, then attach the shish kebab skewer or a pencil to the mousetrap with zip ties. I like to put some craft sticks on the end to make it easier to tie the string to it. Wrap the other end around the paddle wheel pencil, and remember you need enough string so that your stick can lie flat.
Okay, let's try it out.
Wind up the paddle wheel. This will be a little hard as the spring will pull back, but that's where you're storing the energy. And when it's wound up, put it in the water and
Let it go. The paddle wheel turns because the mousetrap is transferring energy that we put in earlier, and it goes all the way.
we stored the energy in the tension of the spring. Now that tension is pulling the mousetrap, the stick, and the string, which turns the paddle wheel and makes the boat go.
Mousetrap-powered boat!
If you want more detailed instructions or other designs, look up Mousetrap Boat.
And there you have it, the Mousetrap-powered paddle wheel boat. And this is what we're going to max out today. Come on. And here's how you can make a tumble wing of your own. But first, a word about paper. Did you know that paper comes in different weights? The kind of paper you get from the printer is actually pretty heavy. The ideal paper to use for tumble wing making is from a phone book. You may not have a phone book at home. They're kind of rare right now, but its paper is very, very thin and the perfect for tumble wing flying. Now, if you don't have a phone book around, you can use newspaper. It works almost as well. What you do is you cut out some strips of paper, and you just need 2, and you put them on top of each other, and then you offset them, which means you take the top one and you slide it over till there's about maybe a centimeter, 2 centimeters, something like that. And then you take your handy dandy science tape, which is the same as regular tape, except you use this tape only for science. And you tape the edges very carefully like that, and flip it over to the other side. Make a little tape on this side, just like that, and there you go. You have a big mouth tumble wing. Now you also want to tweak it just like you do with a paper airplane. You want to curl the paper a little bit, curl this side a little bit, and let's see how it flies. You'll know you have it right when it doesn't go to the left or right, but just opens up and tumbles straight down. Ah, not too bad. That one curved a little bit, so I'll have to tweak it a little more. Now, the other thing you're gonna need is a nice hard surface. The kind of signs that you get when there's an election are perfect. I happen to have a few of these sitting around, and they are made of something called corrugated plastic. They're very light, but they're also very hard. So you can use this, but you can also use cardboard if you don't have any of these around. So what you wanna do is get your tumble wing and your hard surface and flip it in the air, get it flying very nicely, and then walk behind it with your board, and a scoop of air will be behind it, and it will fly. But what if there was a way to release all of that carbonation all in one go? Well, there is, and for this experiment, all you need is your favorite brand of fizzy drink, Science Max brand Diet Science Cola, 100% science, 0 calories. And your favorite candy, like these Science Experiments. All the minty flavor that comes from pure science. So, all you need to do is open this up, take one of these, and put it in here with an adult's permission because it can get kind of messy. Whoa! What's going on here is all of the carbonation that was in the bottle is now being released much more rapidly than it would have been before. Now, why does this happen? Well, If you look at a carbonated beverage, you'll see that the bubbles don't come from everywhere. They come from the inside of the glass, or in this case, a lot are coming from the straw. And that's because the carbon dioxide bubbles like to find a little imperfection, something to hold on to in order to expand and bubble out. And a candy, such as this, has a ton of little tiny microscopic imperfections. So when you drop it in, there's a lot more places for the bubbles to attach, and that makes the carbonation happen a lot quicker. But remember, this is not a chemical reaction. It all has to do with carbonation.
My name is Phil, and I take your everyday science experiments and do them big. This is Science Max, Experiments at Large.